Hi guys, time for another update video in the dead metal build. Today is the 14th of July, so there is exactly a month until, well, a month and a day until RoboNerd's online, but I'm wanting to do the dead metal kind of reveal trailer the day before, so I've got a month today until that's going to be done, but I'm probably going to be filming that slightly earlier on, so I've got even less time to get everything built. But to give you a quick update of where I am at the moment, first of all, the saw. Just this morning, at 8:15 this morning, the door went, and this beautiful thing arrived. This is the friction saw blade that will be used on dead metal. It's 3mm thick, 350mm diameter, and there are 220 teeth on this blade. So that's pretty much the same dimensions as the original dead metal, obviously, and that's what's going to be cutting through test objects, opposition, well, not opposition, but opponents in demos and so on. So I got two of them, so that I've got a spare just for if for whatever reason that one goes blunt, I can swap it out. So just to let you see, I don't know how well the teeth profile will show up there. So yep, 220 small teeth like that, revving about 5,000 RPM I think, so that it should bite through very nicely indeed. Some of the other stuff I got as well, on Friday last week I got a huge pallet delivered, which has given me a sense of the scale of this build because I've never had robot stuff delivered on a pallet before. And what was on that pallet was all the chassis parts that I'd designed in CAD and got laser cut. So to give you an example, that there is one of the claws. So we've got two of those. It'll be the dead metal pincers that we're all very accustomed to. There are various other bits and pieces as well. In this box at the back is all the kind of smaller stuff that will make up little brackets, hinge points and so on. I've got a lot of steel on the worktop here. So stuff like that, which is about 1 meter long. These are the side panels of the base plate. So they're very nice. Just to say as well, these were all laser cuts. The quality of finishing these is absolutely fantastic. I've never had stuff laser cut before, so it might be like this for loads of folk, but I was just really impressed. And quick turnaround as well. I received it on Friday and I placed the order the Friday before, so it was a week between placing the order and getting it delivered. And this here is the base plate. About 10 kilos worth of steel, 3mm steel. So that's going to be the base plate, which all the stuff mounts on. So that'll have brackets for the actuators that move the saw forward and back. What else will it have? The uprights and pivot points for the 4-bar linkage as well. And then obviously the battery and the speed controller, all the kind of gubbins will rest on the base plate as well. So that's quite a large bit of metal. And then the some parts I'd ordered last week, 2 weeks ago, were the pneumatic rams for the robots. These were coming from China, and the eBay site said that they would probably be delivered somewhere between end of July and the 10th of August. So it was going to be pushing it to get them, have them arrive and get them installed before the reveal. But the day before yesterday, they turned up as well. So everything's pretty much arrived at the same time, which is fantastic because it means I can just crack on with the robot, and I've got all the parts here that I need. So there are two of these. These are 50mm bore by 200mm stroke. So that's it fully extended, and that's it going in. These 200mm stroke rams will be used on the saw mechanism to move the saw forward and back. It's got one ram that extends out to move the saw forward, and then the other ram sits in kind of that orientation, so when the saw moves forward it actually retracts, and then to bring the saw back it pushes out to move the saw mechanism backwards. So 2 of those for the saw mechanism, and 2 smaller ones, dinky little rams. These are 50mm bore, again 100mm stroke, so very, very short stroke. These are slightly smaller than the bucket rams in shunt. They're 150mm stroke, so these are just 100s, and these will be for the adjustable ride height or adjustable drivetrain on dead metal. So they sit kind of vertically at kind of an angle, and then to bring the wheels down they extend and the whole wheel frame assembly pivots down. So pretty much the majority of the parts are here that I need to get started building. There's a few other bits and pieces, steel work, metal work, pipes and so on, that I've got on order. I'm just waiting for it to arrive, but I've got pretty much everything that I think I need to start building, so let's make a dead metal. The first part of the dead metal build that I've kind of been focusing on are the drive pods that make up obviously the drive assembly. I've cut some various lengths of steel bar which form the pivots and some of the drive shafts as well. The setup for the drive system on dead metal is a 2-stage reduction. So we've got the 24 volt 800 watt motors that will be driving it. These run on a timing pulley. First stage reduction from the timing pulley to a larger pulley, which is that one there. So that does your kind of first stage reduction, and then the second stage is just a chain and sprocket setup, so your kind of traditional chain and sprocket. So what I've just been doing so far are the wheels we've got here. 12-inch cart wheels, same as the ones on shunt. The rims are split rims, so they come apart in the middle rather than kind of standard go-kart hubs these days, which are one-piece assemblies. So the 2 rims go together, the inner tube inside and then the tyre obviously on the outside, and then I've just got a kind of standard split rim hub bearing on hub and bearing on the front here, just a corresponding bearing on the rear as well. So the drive shaft will go through this, and the wheel will just spin like that. There are also 3 holes in the split rim, and I've drilled 3 corresponding holes on the sprocket. And I also, when I did the laser cutting, I got a drilling template done, just something really simple. It just went over the sprocket and made sure that these holes were all concentric, so that the wheel spins true. And assuming that my drilling is accurate, then that'll be the case. All I need to do, I've got some length of M8 threaded rod there. They'll feed through, well, first of all, they'll feed through the holes in the hub, and then the sprocket will just go over the threaded rod studs, and they'll all be secured with nylock nuts, and that will form the kind of end stage of the 2-stage reduction for the drive. So yeah, I'm just going to fit those. And with all, I've got quite a few shafts cut here, so They're the rods that will form the pivot points for the drive assembly. Hinging, and we've got the shaft for the mid-stage reduction, and this shaft here, 20mm, will be going through the go-kart wheels, and that'll be the main shaft that they rotate on. So I've just spent most of the morning, most of the afternoon actually, it's 3:10, just getting all that cut to length, and yeah, just going to fit it all together.
All of the details are lost in an hour or two. I can't get enough, I can't get enough, I can't get enough of all of the people that tell me it's all in my head. Well, maybe I'm a vampire, sucking all your blood, and that's why you feel so drained when I'm around a lot. Let my bed become my whole world. I'll avoid the day I'm wasting waste away.
So the drive pods at the moment are pretty much ready to get welded up. This is one that I've just put up in a kind of mock-up assembly. So we've got the two long plates that run the full length either side, a plain plate on the front, and a plate on the back with the pivot rods for the adjustable drive height. Get rid of that slag. Yep, motors, scooter motors, 24 volt, 800 watt. They'll be going into brackets which will have braces on this point as well. The motor pulley onto the mid stage pulley, which turns this shaft, and that will have one of those sitting on there. So as that turns, that'll turn as well. And then the go-kart wheels, which we were working on earlier, have now got the sprockets attached on the back. I need to trim down the bolts obviously, and they will sit in that shaft there. There's a nut on the end that's going to get welded onto the plates. The shaft itself is a static shaft, it won't turn. But I'm going to run a 12mm threaded rod through this shaft, which is hollow on the inside, and it will thread onto that nut. The reason for not bolting it on the far side there is that there's only going to be 5mm gap between this plate and the main base plate, so there's not really any room for a nut on the outside, so I'll just pop that on the inside, and then yeah, the go-kart wheel will sit. I'll just kind of sit in there. So it's quite a compact drive setup when it's all together. I still need to order the belts because I need to work out what size they need to be first of all, but once I've got everything in place, I'll do that. Sucking all your blood, and that's why you feel so drained when I'm around a lot. Let my bed become my whole world. I'll avoid the day I'm wasting waste away. Wasting So this is the mostly complete wheel pod. So we've got the go-kart tyre in the front here. So that's just running on 2 bearings, one inside there onto the shaft, and I don't know if you can see the other one's just in there. Got the large sprocket on this wheel. The good news is it seems to be running relatively concentric and without wobble. Above that we've got the smaller sprocket, which will be coming off the mid shaft. So you can see that turning there, and that's me turning it, the large pulley, with my hand. The motor will sit across here with the small pulley, which will be going onto this big pulley. We've got 4 bolts that I've welded on there to double up as studs. So the motor mount will sit on here, and I've just got this plate which goes on that way. So the plate's slotted so that it slides up and down, and the reason for that is just so that if the tension's slightly slack or slightly too tight on the timing belts, I can adjust the motor mount to slacken or tighten so I can get the optimum tension on it. There's the 2 screws that I used to act as grub screws on this pulley. My tap wouldn't fit in the full length, so what I've done is I've drilled this out with a 5.2mm drill bit, tapped it for a helicoil, and the helicoil probably sits about maybe there, and then this bolt just threads all the way through onto the shaft, and then there's a second one at 90 degrees which just helps lock it on in place. So that's the first one, pretty much done. Second one is here. Still needs to get the shaft fitted in place and the bearings and everything fitted. So I'll be doing that first, and then I'll get on with welding the motor mounts, and hopefully by the end of today, with the exception of the timing pulleys, timing belts, which I still need to order, hopefully the wheel pods will be complete.
With society that we signed long ago when we were younger, back when we still had a future. Now we're sitting at a table.
So after a bit of work, the wheel pods are finally done. Come and take a look at this. Here we have a completed wheel pod. So starting from the front, we've got the 12-inch kart tyre. That's running on a 20mm shaft, hollow shaft, with a collet on either side. I don't know if you can see that one in there. Oh, there it is, silly me. Yep, 20mm shaft. There's a M12 threaded rod that I've got a nut on one side here, and that just threads through and pokes out the other side of the frame. The sprocket on the kart tyre then runs to the smaller sprocket on the mid-point drive shafts. I've got the timing pulley here, so turn that, and that turns the sprocket, which will in turn the wheel. Also got the 24V 800W motor mounted here. These are on slotted base plates, so what that allows me to do is wrap the timing belt round here, and if it's too tight I can move it this way a bit to slacken it off, or if it's too loose I can move it that way a bit to tighten it all up. Timing belts have now been ordered. Now that the motor mounts have been fitted in place, I could measure up and order the timing belts, so they should be here by the weekend hopefully. And yeah, just a couple of, ignore the welding, it's mostly just tack welded at the moment, but a couple of support braces on the side there just to keep this frame rigid. So yeah, that's one drive pod there, and the other one down there. Exact same, just mirror imaged. So yeah, literally all that needs to be done now for the drive pods is install the chain, obviously for the sprockets, and the timing belt as well. So the timing belts should be here in a couple of days' time, and I'll just do the chains at the same time, just rather than doing one just now and doing one later, just do it all at the same time. So hopefully within a couple of days I can apply voltage to the motor, and all being well, the go-kart wheel will turn. Got some wheel belts. So timing belts have turned up for the drive system. I'm just going to test fit them and see how it goes. Drive pod in place. These are 475mm diameter belts, and just on first impressions, they're a little bit on the short side at the moment anyway, but these motor mounts are on sliding plates, so I shall loosen them off and see what we get.
But your logic's from a playground at a school you can't escape from. I will make my way outside. Will I make it out on time? Not
So, belts on. I was just going to do a quick video showing the motor turning the belt, but I thought that's not really that interesting. Let's put the chain on it. So if I bring the camera down, now got the chain on drive. There's a bit of slack in there. It's got a half link and a full link joining it to get the right length. If I take the half link out to remove that slack, then it's too tight and I can't join it, so I really need a quarter link, but I don't think you get quarter links. So I'm just going to have to run with it as it is. If the chains are at a point where they're jumping off regularly, I might just need to look at making a tensioner to go inside. But at the moment, so you can see the belt turning here, and the wheel turning. So if I turn the belt by hand, you can see this turning. And I thought, well, why don't I just put some power to it? So I've got it hooked up to 12 volt supply at the moment. Here goes. I'm going to call that a success.